Hi everyone, it's Mrs. Martello. We're going to look at section 7.4. I'm on page 378 in our textbook. So today we're going to look at using the zero product property. So a polynomial is in factored form when it's written as a product of factors. Remember, factors are things that multiply together to give us that product. So in standard form, it looks like a regular expression where you have either two terms or three terms or however many terms you have. Factored form looks like two expressions being multiplied together. So this x is its own expression and x plus 2 is its own expression. Or in other words, there's two polynomials. So this is one polynomial, which would be a monomial because it's one term. This is a second polynomial. It's two terms, so it's a binomial. Or you can have a binomial times a binomial. So it's when you have a product of polynomials together. So when one side of an equation is a polynomial in factored form and the other side is 0, you can use the zero product property to solve the polynomial equation. The solutions of the polynomial equation are also called the roots. So the roots are just another word to mean solutions. So here's what the zero product property says. If the product of two real numbers is 0, then at least one of the numbers is 0. So if a and b are real numbers and a times b equals 0, then either a has to be 0 or b has to be 0. The only way to get 0 as a product is if one of the factors is equal to 0. So let's take a look at example 1. We're going to solve each equation. So in the zero product property, I have 2x times the quantity of x minus 4 equals 0. The only way that this product could equal 0 is if this first factor, 2x, was equal to 0, or this second factor, x minus 4, was equal to 0. So that's what we're going to do. We're going to set each factor equal to 0, and then we'll solve. So our first factor, 2x, set it equal to 0. Divide both sides by 2, you get x equals 0. Our second factor, x minus 4, set that equal to 0. Add 4 to both sides, you get x equals 4. So the roots are x equals 0 and x equals 4. Both of these would make the equation equal to 0. Let's look at the check. So if I wanted to check, all I would have to do is take this 0 and then take the 4 and plug it into the original equation and see if it actually makes it equal to 0. First, let's plug in 0. So 2 times 0 times 0 minus 4, does that equal 0? Well, 2 times 0 is 0. 0 minus 4 is negative 4. 0 times anything is 0, so that one works. Now let's try plugging in 4 into our original equation. So it'd be 2 times 4 times 4 minus 4 equals 0. This would be 8. 4 minus 4 would be 0. 8 times 0, yeah, that does equal 0 too. So both of these are the solutions. So they're both called the roots. Again, the roots is just another word for solutions. Okay, here's another example. We have x minus 3 times x minus 9 equals 0. We're going to set this first factor, x minus 3, equal to 0. Add 3 to both sides, you get x equals 3. Then we'll set this second factor, x minus 9, equal to 0. Add 9 to both sides, x equals 9. So the roots are x equals 3 and x equals 9. Okay, we're going to do monitoring progress number 1 together, just so that we can see it. So in monitoring progress number 1, I have x times the quantity of x minus 1 equals 0. So this is in factored form because I can see it's something times something equals 0. I'm going to take each factor and set it equal to 0. So our first factor is x. I'm going to say x equals 0. Or our second factor is x minus 1. I can say x minus 1 equals 0. Well, our first one is already solved. I don't need to do anything to it. So x equals 0 is our one possible solution. For our second equation, I'm going to add 1 to both sides, and I get x equals 1. That would be our second possible solution. And that's all we have to do for those. Okay, let's go over to look at example 2. So it says when two or more roots of an equation are the same number, the equation has repeated roots. So it is possible to have two of the same roots. So in part A, 2x plus 7 times 2x minus 7 equals 0. These two have two different factors, so these will have two different roots. So I'm going to set each factor equal to 0. 2x plus 7 equals 0. And then I would subtract 7 from both sides, divide by 2. I get x equals negative 7 over 2. And then 2x minus 7 equals 0. I would add 7 to both sides, divide by 2, get x equals 7 over 2. So this one has two solutions. Let's look at B. It says x minus 1 squared equals 0. Remember what it means to be squared. Squared means that it's something times itself. So this is really x minus 1 times itself equals 0. So instead of writing it as squared, I can say x minus 1 times itself, x minus 1, equals 0. Now if I set each factor equal to 0, these end up being the same exact equation, x minus 1 equals 0, x minus 1 equals 0. You get the same answer for both of them. So this equation has a repeated root of x equals 1, which means it only has one solution for this one. Let's look at letter C. I have three factors for this one, x plus 1, I have x minus 3, and I have x minus 2. I'm going to set all three factors equal to 0. This is going to lead me to three solutions. X plus 1 equals 0, I get x equals negative 1. X minus 3 equals 0, I get x equals 3. And x minus 2 equals 0, I get x equals 2. So again, I have three solutions for this one. All right, so that's the zero product property. Okay, we're going to take a look down here. We're going to start factoring our polynomials. The first way we're going to factor our polynomials is by using the greatest common factor, the GCF. So to solve a polynomial equation using the zero product property, you may need to factor the polynomial or write it as a product of other polynomials. So if our expression is in standard form rather than in factored form, we're going to have to factor it to make it in factored form. So look for the greatest common factor of the terms of the polynomial. This is a monomial that divides evenly into each term. So when we're finding the greatest common factor, make sure you're looking for the greatest common factor of the numbers and of the variables. So let's write that down. When you're find the GCF in a polynomial, the first thing that you want to do is you want to find the GCF of the numbers. Finding the GCF of the numbers should be pretty straightforward. You should be able to find the greatest common factor of just any two numbers. So for example, if the numbers were 4 and 12, the greatest common factor would be 4. You're finding the biggest factor that is able to be divided into both of those terms. The second thing you want to do is you want to find the GCF of the variables as well. When you're looking for the GCF of the variables, there is a clue, an easy way to find it. You want to look for the smallest exponent. So you're going to use the smallest exponent. Okay, and that's just a little trick that I have come up with to help me find the GCF with variables. So let's take a look at this example here. So in example 3, it says factor out the greatest common monomial factor. So this is a GCF, but a monomial of 4x to the 4th plus 24x to the 3rd. So if we're looking at just the numbers, just 4 and 24, the GCF of 4 and 24 would be 4. Now we want to look at the GCF of the variables. I have x to the 4th and I have x to the 3rd. I want to find the greatest common factor of those variables. Well, I know that x to the fourth is really x times x times x times x. It's really 4x's. And I know that x to the third is really x times x times x, so 3x's. That means that in this term, I have 3x's. And in this term, I also have 3x's. If there are 4x's, then 3x's would fit inside of it. So the greatest common factor would be x to the third. So if I put it together, the greatest common monomial factor is 4x to the third. So I'm going to take 4x to the third out of each term and put it in front of a set of parentheses. I'm going to divide it away. So 4x to the fourth divided by 4x to the third. Well, the 4's cancel out, and I just have one of those x's left. 24x to the third divided by 4x to the third. 24 divided by 4 is 6, and the x to the thirds cancel out, so no more x to the third. So this would be our factored form of our expression, 4x to the third times the quantity of x plus 6. Let's do one together here. We're going to look at monitoring progress number 7. I have 8y squared minus 24y. Okay, our first step is we're going to find the GCF of the numbers. I have 8 and 24. I know that 8 goes into 8 and 8 goes into 24, so 8 would be my GCF of the numbers. Now let's look at the variables. Our variables, I have y squared and I have y. I'm going to select the smaller exponent, so it would just be y. 8y would be my GCF. Now I'm going to divide 8y out of each expression. Personally, in the beginning, I find it easy to literally show that I'm dividing each expression by 8y, and that helps me to think what would I have left if I take 8y out. Well, these 8's cancel out, and then y squared divided by y, remember you subtract the exponents, this would be y to the first, so this would just be y. Keep the minus sign in the middle. 24 divided by 8 would be 3, and then y divided by y, these y's cancel out, so just 3. So this would be our factored form, 8y times the quantity of y minus 3. Let's do one more. I'm going to just create an example here just so that we can see another example. Let's do 3t squared plus 6t. Okay, first let's find the GCF of the numbers. I have 3 and 6. The GCF would be 3. Let's find the GCF of the variables. I'm going to pick the smaller of the exponents, which would just be t. So 3t is my GCF. Now I'm going to divide 3t out of each of these terms, and that's going to tell me what I have left in this second polynomial in here. So the 3's are going to cancel out, and let's divide t squared divided by t would just be t. Carry over the plus sign. 6 divided by 3 would be 2, and then t divided by t, these t's would cancel out. So this would be our factored form, just like that.